Do you hear me well?
Yes, everything's
Okay,
okay.
great. So I'm Dmitry Levashov. 15 years ago, I was graduated on a cafeteria you are currently now. Dmitry invited me today to basically tell a bit about ML system design and again to share some useful things. Let's a bit arrange on a format. For me, I expect not only talking but also some level of communication. But for me, the best language to do that is English. But if you want to ask anything, add comments, so to tell something, feel free to use any language you feel comfortable for you. So we can move then to the lecture itself. Let me share my screen. Do you see it?
Yes.
Okay. Dmitry, it seems that our dialogue will be with you, but I always enjoyed it, so it's fine. The idea of this story is to connect different areas and disciplines and give a bit view from a side. How can we build system, how integrate to external world, but also how to align expectations and how basically take common model and make this model collaborate in a productive way with the rest of the world. First question I want to ask you is, what, on your opinion, is a model? Okay, Dmitry, don't share your thoughts. Then I'll share mine. Basically, I propose to look on a model as an approximation of a process. Generally, it's true for any model. It might be true for machine learning modeling. It's true for any semantic model. It's also true for any model in chemistry or physics. When we think about this approximation, we could find three different components for it. So first of all, it's algorithm. Basically, it's a core of our model. It's defined what it can do, what kind of dependencies it could approximate, basically it's also is defined by artifacts, by coefficients of the model, which customize behavior. If we think from perspective of formulas, it will be something like so when we set f in some attributes, that would be it. So this is an algorithm. Let me color it a bit differently. Yes. Okay. Usually when we set a core of algorithm, it's approximate something, but for most of cases, we want not just a random process, we want some exact process to investigate it, to get some patterns out of it, etc., etc. So the second component would be optimization. And for optimization, we have, again, two things to mention. It's optimization goal. And overall, it might be a person that sits next to you and say that this is good, this is bad. Or it might be a loss function or anything else. For our purposes, for machine learning, most commonly we would like our optimization criteria be differentiable and to work with it and run some optimization methods. And optimization method is just how you find an optimal value using your optimal criteria. So nothing more than that. Basically, when you say that you have a function and you want optimize it, Please set up. This is common RMCA criteria. You set the goal and which you want to achieve. And the third component of any model is in our knowledge about environment. It is data we have, and also it's some a priori knowledge. Some architecture allow to add that directly. For some, you need some tricks. For example, if you want to train your neural network a fact that ball will fall straight down, if there is only gravity, you will need some tricks to apply. Okay, but this sets basically a framework for modeling, and it's pretty commonly used for all of us. The trick is that if we take it and go to production environment, in a lot of cases, it will bring a perfect model that wouldn't fit any expectations for different reasons. Because people expect different results from you because infrastructure, because just a lot of different reasons. And let's look on a scenarios how it might be organized and how we can deal with it. So, and I will start from three purposes for which people usually apply modeling. First of all, it's research. The goal here is pretty straight. We want to get extra knowledge about our environment to understand more. And what we want to get from the model, well, first of all, it should be good. We can reproduce it in an easy way, so we can run it in any time and rely on results. They should be stable, and it should be explainable. Sorry. It should have a good explainability level. Basically, if you train a black box over your data and you could get a pretty limited amount of information out of it. Second one is decision support. Specific of it is that you don't really do a research one time. You want to build a model that will continuously retrain itself and provide some insights for people who could do certain decisions. The trick is here that the model should be robust. Basically, you should let it run and people should rely on it and with a high confidence level. Otherwise, they will not use it. It should be always up to date, and your insight should be easy to interpret, because if you provide, for example, even common correlation to some business people, in a lot of cases they will not understand what exactly you mean. I mean, a level of correlation 0.5 or 0.6, what is critical for them. So it's better to convert some graphs and some concrete conclusions. And third one, the most broad, is the process control. And here we, surprisingly, we mostly rely on stability of a model and infrastructure. So we need a model that is has low error tolerance. That means that you shouldn't, if you expect any case where it could break, you should cover it. So the easiest thing to do is to set certain response in a backup. It should be fast, because usually you interact with people that are waiting for this response and you don't want them to wait. And it should continuously retrain and control itself, so you need a really strong validation system there, because for decision support, you have a person and they will give you a negative feedback if something goes wrong. If you control process, well, if your self-driving car will reach a tree, the feedback is too strict. Let's look on how flows, implementation flows for each of these purposes looks like. For research, it's much better to ask your professors. I mean, because in science this is much more common. Basically, you build a model, you extract knowledge, and you present it. And theory is important because basically, well, especially last time, because if you don't share your knowledge and it stay in your chest, well, they are pretty useless. It's much more tricky when you want to put your model into production. First of all, you need to implement it. So to put it to fit to a formal criteria, align input and output, you should evaluate it, because the rest of company usually don't really measure success in accuracy or log loss. You need business metrics for it. And you need to set up a retrain process where you should take into account that usually if model makes certain decisions, it bias itself in future. So it becomes pretty tricky challenge for you. And of course, you need to monitor all these stages to guarantee that everything works. So far, do you have any questions? Okay, all my story is really clear, or it's definitely not. Okay, then let's move forward. So, how to deal with this process, and how can we fit our, how can we manage expectations, how we can align what we're building with what people expect and to deliver something. Usually I use a framework of setting functional and non-functional requirements. Functional requirements is what actually systems should do. And usually we answer, to get it, we answer questions: what it should do, why it should do it, how we will use it, and try to analyze the corner cases. And the most basic thing here is to start from business expectations. So you need to set a business flow, or in some broader systems, you need to understand, you need high-level description of the system to understand with what you are dealing, and to communicate that transparently to another stakeholders. Based on this information, you can set several important things. First of all, you can set a criteria of success. We have business KPI called here. You can select what implementation flow you would go, and you can split a flow to stages to basically to understand what is your work and what you should outsource or ask for help. Having this information would move you further, and you can define architecture. Basically, it's pretty easy, because for each task you have more or less common solutions. After you know what to do and how you want to do it, you can check data, and in ideal scenario you will have everything in one place. In realistic scenario, you will deal with handwritten data, manual inputs, and a lot of misalignments. But this is what we're used to. You can set, by answering question why, you can select optimization goal, and also basically loss function for your algorithm. And then you can move to practical scenarios and decide on how to adjust your loss function to understand cost of mistakes. That's a really interesting thing to have because when you design, for example, algorithm for disease detection, if you say that you are if you have false positive, basically the person will go to quarantine because of your decision. If you have false negative, the person will go outside and spread disease for the rest. Well, these cases are different, and so they should be valued differently. Perhaps you don't, for classification, you need not F1 score, you need some weighted scores. And of course, you need to set other steps of the funnel here. You need to decide on retraining. You need to decide on what you will use for testing. And most commonly, that is split test, where you say that half of your clients will get one case, second case, and then you compare results. But for a lot of situations, it doesn't work. And of course, you need monitoring because if you try to think what could go wrong, just trust me, it could be any step of your funnel. There was a really good example that Microsoft shared. They ran a split test on news sorting in Bing. Basically, they add an algorithm on a machine of a customer just to adjust sorting. The trick is that they found that it overloads the battery, and all laptops start using their battery power much faster. So basically, good sorting fails just because they hadn't taken into account the condition of machines. Last but not least in functional requirements is to think about corner cases. And for corner cases, it's you need your imagination. You can't foresee in advance what could go wrong. Anything could. So you just need to cover the weakest points, set a monitoring that covers as much as possible, and based on it, add limitations, deal with cold start problem, etc., etc. This is shortly about functional requirements. Do you have any questions?
Questions for now.
Small clarifying question.
Sure.
So for every scenario, we need different solutions. So we don't have universal, right?
Yeah. Basically, you can use the same solution for all scenarios. The trick is that main criteria how people would rate your solution would be different. Because if you train a model to get some knowledge, for research purposes, you can wait for a response for a week. It's fine. Like everyone is waiting. There is no deadlines. But if you implement something that thinks for a week in production for, I don't know, for some deal support, for negotiations with suppliers. In a lot of cases, no one will wait for it. Because when negotiator come and want extra information to deal with, they won't answer now. So it's you can use the same approaches for different for different goals, but you should understand that basically for each goal you can't build ideal model. You should narrow it down, and
yes.
things that you will narrow down depend on a purpose of implementation.
Yes, thank you.
Okay, any other questions? Okay, let's move forward. Next thing to deal with is non-functional requirements. If to say it in few words is just how fast, how technically it should work. So how fast should it be? What amount of data should it process? What security measures? And of course, how much would it cost for a business? There are certain critical things that you need to take into account. And first of all is time and complexity. When you and it highly depends, of course, on a purpose of your system. Usually, I used to split to different parallel processes: execution, basically a prediction of model, and training, because most of my system worked as a process support system. That allowed me to train in the same time, train model in the same time they bring value to customers. But I know there are setups where you need to stop the model, stop responding to customers just because of security reasons. At least in banks, it's pretty often when functionality is not available, just to guarantee a certain level of accuracy and security. You should, of course, here deal with data availability, because usually databases are huge, and not all pipelines could guarantee that you will get the latest data in time, especially if you need it in almost real time. Usually, for any system I worked with, 1 day delay is a standard. So if you train data on if you train your model on data from yesterday, that's fine. Second thing you should is really important is complexity of algorithms you use, because usually we train system on a small subset of data, but how would it work if amount of data will triple? If, for example, you forecast credit score not for one person, but 10,000, would it still work with it or not? And again, it's better to estimate it from perspective of computation and complexity of execution part, so basically of algorithm, and also for training, because there is pretty funny algorithms. For example, when you try to estimate, so in commerce, you pretty often might face with a task of product cannibalization. Idea is the following: that if you show customer one product, they will buy it with a chance A. If you give him 2 products, the chance of buying first product will decrease. So to get this score, you need to run certain model and estimate the result, the cross influence. The trick is that complexity of this model is not linear, and the amount of pairs is square of amount of products. So if you test your algorithm and it work on 100 products, that doesn't mean that you can run on a swarm of million products, just because of lack of time in the universe. Yeah, and then basically, it's mostly related to GDPR and regulation in Europe. You need to check how well encrypted and isolated your algorithm is. So you can, here you can't process sensitive data. For example, you can't process customer ID or his email in open format. So you need to take a hash out of it. Usually for it, we use standard algorithms, but you should keep an eye on it. And last but not least is to compute basically how much money this system would bring to basically to business, because well, almost none projects are done to get a pure knowledge. Usually companies want to get something out of it. And so far, I find the most useful framework to estimate importance of a product as ROI. return on investment. So you take your estimation of what it will bring based on increased accuracy or based on some time that will be saved by people who make a decision, divide by amount of time you will spend for it, plus costs of maintenance, -1, and you will get a percent. And if it's above 1, then you can say that it's brilliant. Oh, sorry, above 0. Then you can say that it's a good project and there is some sense to build. If not, well, better to find something else. So this was a core of things I want to share, and my common question. And do you have any questions?
For me, everything is clear, except my first question.
Sorry, you start talking, but I didn't hear.
For me, everything is clear.
Oh, okay, yeah, thanks. Good. Then we have now several ways to go. First of all, I have an example we can do together. Basically, ML system design for recommendation engine for Rosetta. We can check how it might look in code. Basically, how to organize data science project and how usually it looks like on practice. Or we can go to a completely different scenario, and I'll show how basically work on with a request would to do all stuff around machine learning without actually going deep in modeling. Which topic is the most interesting for you?
I'd like to hear second, but I don't know what about others.
Okay, so chat, the last one. Okay. I think each of those will take approximately 20 minutes, so we will fit. So I propose then to go to code, and so you will see it. Do you still see my screen? Basically, right now you should see a code editor.
Yes.
Okay.
No,
So,
we can only see the browser window, not the code editor.
oh, so you still see browser. 1 second. Let me change it. Okay.
Yeah, it works now.
Okay, great. Thanks a lot. So this was one assignment I did in past, and just to give you a feeling how usually it works. What you get as an input, you get a person that comes to you and say that he want to improve certain functionality, or he want to get some business request. And thing you need to define on the first stage is why he want to do that. Basically, some description of environment and goal. But based on this data, you can understand what actually you do, and you can align your expectations. After it, you can go to data and see what actually it looks like. Here I got pretty simple setup because I got a session data with some country information, with URLs, and sorry. Basically, and it was labeled. My task here was to improve labeling mechanism versus what we have initially. So this data was labeled $500,000. And first thing I think you need to do is look on your data and understand what extra can you get from it. Usually I run through the pretty simple check. This data is all categorical. So I check amount of rows. I check amount of unique cases, so basically to understand what I can use as a feature or whatnot. And percent of missing data to understand basically what should I cover. In this specific case, I form the list of things I can do. So I can filter because, sorry, but no one deals with 66 countries. I can get some extras from URL. If you see here certain parts which could be parsed. Later I'll show what I've got. Then reference in most cases is missing, so take it as a KPI is not the best idea. So I decide to take just existence of it. And I decide to check seasonality because these are milliseconds, and perhaps I can get something out of it. And of course, I decide to go to a smaller amount of classes because some of them are pretty useless. Basically, here you can see that some classes has only few records, and they're just not important. Like no one want to track two requests from cloud. Just then comes a wrapper around it. And here is the best way to, the diagram, which is the best way to show that your classes are unbalanced. And already on this stage, you can say that classical precision or recall wouldn't work. Basically, F1 score wouldn't work neither, because you need balance it by classes. That's why later I'll take balance accuracy score as a main evaluation metric. Yeah, and basically that's why I select algorithms that can work with it. Then pretty straight checks for country and regions. Here we can see a distribution of countries per share in total. So more each dot represent country, and more it lays to right, the bigger share it has. And also we see amount of share of non-real cases. So basically what we can see here that there is one dot that covers almost all non-real cases. The same for other segments. Let's go briefly. Time series analysis, quite specific card. Here it was enough to see that there is only 2 hours of available data, and I decided that I can't extrapolate it. So if you can't extrapolate decision from your data set to general total data, you can't use it. That's just take it as a rule. Again, parsing URL give us the same picture. Go. So this is just a general things. Let's not go to the details. Sorry that I did it. Basically, what you do initially, you just check all your ideas about data and to get a certain picture, a feeling about data you work with. You can test certain ideas. After you did all that, I do advise you to check feature importance. For you can take correlation, you can take entropy. Personally, I, for category data, prefer mutual information, that basically a measure that is based on conditional entropy. Here we see that one of the features I propose is bad. We drop it. And next important thing is to gather all your findings in one function. Because in all systems you will need multiple times to process your data, and if you will have it separately, you will definitely on one moment stuck or misalign something or forgot. So just take it as advice. You should put everything in one place and organize it as good as you can. Because this function here, you will like to change it later. then pretty standard way. So there, in most cases, when you will work with production data, you will not write your own model from scratch. You will use components from different that are already implemented. For this assignment, I test naive bias. I use nearest neighbors, and I want to use CatBoost, but unfortunately, it doesn't work with multi-label data. Small wrap around it works. Next, after you get a certain basic model, you want to find which parameters are optimal, and you want hyperparameter tuning. Basically, it's the same the same task of model optimization, but as criteria you take not how basically you just run more iterations through your code. To this part I put everything that's possible. So I put I replace split into test trained data set with scaffold, put a lot of parameters because I hadn't optimized it manually. I just let it to compute during night, etc., etc. So basically classical approach of training, iterative training, using basically using Optuna, this library that designed for hyperparameter tuning. Simple interface. I do recommend you to give a look to use it. Now, well, of course, if you want to deal with it manually, you can. The simplest way is just to research or through all those parameters. Usually, predefined libraries save you half of time for training. After you build a model, you need to evaluate it. You need to check what result does it give on your test data and on your train to understand if it is overfitting or not. Here we see that results are pretty close, so acceptable. Next interesting thing I would advise you to use is a cross top. Basically, it's a matrix, cross matrix that that show how classes you forecast match reality. Because accuracy scores could tell you how good is your model, but you can't really find extra insights what should be improved. Here, for example, we can see that yes, classes are unbalanced, but even though our model is the best, gives the best score, hackers we usually predicting pretty bad, because we also misclassify real customers as hackers. Basically, we will get a lot of false positives here. Next goes prediction of single element. It's not even interesting. It's here. It's usually shown to understand how should you form a response for API for implementation, and to provide information about your model. It's pretty good to show feature importance. Basically, there are standard way to estimate feature importance. Most libraries you will use in production will have it, but if you want to do it yourself, you should estimate what percent of deviation from average certain parameter could estimate. Basically, you can estimate derivative of each parameter multiplied by this distribution of the rest of parameters, and you will get this estimation. This is shortly about it. Do you have any questions we have about certain components? No? Okay. Then I suppose that we are done with this part. And I can slowly move to the next one. This. Okay, this another example how you can deal with problem of ML system design, but from a perspective not writing code, but writing actually design. So the incoming information was to create a tool that would help in discounting policy. Basically, what company does, so they optimize EBITDA based on discounts they provide. And here we can clearly see a basic stage. This is input. That was initially. Then we have a negotiation part where we should clarify how we compute EBITDA, what components it has. This is a term from accounting. You shouldn't really care if you understand it or not. In the end, it's happened that we need to measure influence on just revenue of company. And based on this discussion, we validate what we maximize. We validate some conditions of how we want to use it, and etc. etc. This project I decided to organize in a way of different dashboards. That's another way to basically to deal with it instead of text. As this is decision support tool and I need to present somehow to people, I draw how this might look like. So block with input with certain parameter, block with output, and again, just imaginary things, how it might look like, what extra insight it could provide to people. Then it's pretty interesting diagram. It's the same thing I wrote on the right side, but as a schema where we define input for our system, we define what components it should have, and we output. Basically, it gives an overview of component of the system. Pretty useful thing, especially if you need to talk to some technical people, or to DevOps team that set up infrastructure, or to developers that will implement your code. Next diagram is something that much closer to our domain, is a process of decomposition of target to our knowledge and research plan. So we initially want to forecast gross profit. We say that it could be split to sold amount, price, and costs. Cost and price we can easily define as something constant, because we can compute that easy. And all things we need to do is about sold amount. So we continue decomposing it to topics to understand what actually we would like to build and what we would like to investigate. And I went really to details still, like adding weather to trend prediction, some price elasticity model, etc., etc. What important things here is to understand what researches you need to do for your first delivery and what you need to do later, because you can't do everything in one go. And then slowly after it, we can organize it in a diagram, in a plan, implementation plan. First of all, it's collect requirements. Basically, all these variables are about collecting requirements. Stage one of any implementation is exploration, is what you would like when you want to get as much about data as possible and discuss it with people who know the domain, because even though they don't work with data, their practical knowledge I usually cover much wider range than you can get from data. They can evaluate the ideas pretty fast. Then you would like to build some proof of concept. Basically, this is something ugly that people can touch and say, does it work or not? In my practice, it's usually Excel file or pretty simple Python code that generate dashboard. So this is something you can give to business, and they will tell you where you are wrong. The only purpose of it. Then after you get an approval, you want to implement it as minimal viable product. What is basically the difference between these two stages is that first is something ugly and not maintainable. Second is still the same simple, but fit all pipeline and guidelines of a system you work with. And then you start iteration with improvement. So after you get a stable solution, you can work. But this is more about general pipeline of and processes in the company. So each company has their own guidelines. So I'm pretty sure you will be guided through it. Okay. Do you have questions? No? Okay. So this was information I plan to share it with you. Perhaps you have any questions outside of it. Perhaps I forgot something covered that you would like to know, or any other questions you would like to ask. Tell me, please.
No, it was pretty clear. Thanks for real examples. It was interesting to see how it can be implemented in real cases.
Okay, great. No? Well,
Maybe one
if there
more
is,
question.
yeah, Dmitry, sure.
Yeah, one more question more.
Sorry, Dmitry, may I ask you to a bit tone the
Okay.
voice or write the question, because I don't hear you. Sorry.
And now, can you hear me? No?
I still don't hear.
I know, I can hear Dmitry.
Okay, then perhaps it's something with my ears. Sorry.
Yeah, I can type it. I can type it now.
Yeah, sure.
Maybe while I'm typing. Може, ще хтось хоче задати питання? Така рідка можливість спитати у практикуючого спеціаліста.
Sorry, could you repeat?
А можна українською питанням?
Так, звичайно.
І сподіваюсь на українську відповідь можна. Будь ласка, я там побачила, у вас використовувалось метод навчання наївного байсу. Можна трошечки студентам про це розповісти, бо у нас якраз лекція на цю тему планується наступна.
Так, звичайно. Я спробую розмовляти українською, але прошу вибачення, тому що треба перекладати через дві мови. Без цього. Метод наївного байсу давайте я розширю мій екран і трошки помалюю.
Чудово.
Ідея методу наївного байсу в тому, що в нас є якийсь таргет. І в нас є декілька параметрів системи, які ми вважаємо незалежними. Тобто в основі цього методу лежить байесівські графічні моделі, коли ми хочемо хочемо дізнатися, перепрошую, але деякі слова я буду використовувати англійською. Коли ми хочемо дізнатися dependencies між нашими даними. У найбільш примітивному сенсі це просто таблиця, де в нас є усі комбінації наших даних, і кожну з цих комбінацій ми ставимо якесь значення. У відповідності до кожної комбінації ми ставимо таке значення. Тобто, якщо у вас є занадто багато, щоб малювати таблицю, якщо у вас є дві фічі, одна з x1 та x2, то у вас є можливі значення 1, 1, 1. Ваш наївний байсівський класифікатор, модель, буде виглядати як значення для кожної з цих груп. Наприклад, якщо ви вирішуєте задачу класифікації, це може бути класи А, Б, С, Д. А, Б. Якось так. Це одна з найпростіших моделей, які використовуються, але ж вона в той час дає найбільш інформації, тому що структура, коли ви навчаєте цю модель, дозволяє оцінити не тільки influence, не тільки вплив параметрів на модель, вона також дозволяє працювати з даними, з пропусками даних. Тобто, якщо, наприклад, у вас є тільки x1 та немає x2, ви можете оцінити, які комбінації будуть, яка вирогідність побачити одиниці чи 0 у x2 та зробити prediction для усієї моделі тільки маючи дані. Це я пропонував би розглядати це як базовий шаг к Bayesівським моделям, де коли ми розглядаємо усі коннекшени у даних. Та у свою чергу також ми перепрошую, я тут допустився помилки, тому що ось тут рішення буде ось таке. Сама модель буде трошки інша. А тут в нас буде кількість кейсів, які ми бачимо. Тобто, оперуючи з цими даними, ми можемо казати, що яке найбільш вирогідне значення таргету в нас буде. Це якщо у кількох словах. Наскільки зрозуміло було моє пояснення, та чи потрібні якісь ще більш детальні?
Ну, трошечки було зрозуміло, але сам метод навчання, як він виглядає? Ось метод навчання за допомогою наївного байсу. І що саме ви там навчали? Чому навчали? Яку мережу?
На самом деле, якщо ми поглянемо на як виглядає, по-перше, що я навчав? Я взяв цей метод просто як бейсграунд для моєї системи Devin. Тому ви можете побачити, що він, по-перше, ніякої кастомізації. Як він був, так він і навчався. Формули, на жаль, я не пам'ятаю. Це краще подивитися у Вікіпедії, у якомусь іншому справочнику. Основний принцип у тому, щоб побудувати мережу, яка буде, у якій всі зв'язки, у яких зв'язки не описують dependencies between, окей, зв'язки не описують зв'язки між вашими даними, тільки між таргетом та параметрами.
Дякую. Тобто зв'язки між вхідними там якимись фічами, на як ви кажете, відсутні, да? То
Так.
Незалежні ці вхідні ці дані.
Так. Основна ідея цього методу в тому, щоб отримати якусь картину. Але на практиці цей метод дуже гарно працює, наприклад, з текстовими даними. Тому що це один з доменів, де він не повинен працювати, але ми бачимо, що бачимо гарні результати там. Тобто, якщо ви очікуєте, що є якісь зв'язки, якісь кореляції у ваших даних, то ви не можете його прийняти.
Ага, тобто існує якесь таке протиріччя, що метод працює там, де він не повинен бути працювати, да?
З текстовими даними це контрінтуїтивне observation. Це контрінтуїтивно, але він дає непогані результати.
Якось це не пояснюється зовсім нічим. Приймається
Ні.
як аксіома, так?
Так.
Зрозуміло.
Може, це тому, що до того, як трансформери увійшли у наше життя, текстові моделі, якість текстових моделей була дуже низька. І тому навіть ці кореляції не мали такої великої ролі.
Дуже дякую за роз'яснення. Дуже дякую, Дмитро. А там щось у вас є в чаті, якісь питання? Будь ласка.
Давайте подивимось. Так. How can I do that? Ага. When it's time to retrain. Basically, most of processes I prefer to set off in iterative improvement way. So that you can't say model is good or bad. You can say that is it better or worse than previous iteration. And usually when you deal with data, you need to, with data issues, the thing you need to set is the accepted delays and accepted so basically it's more a thing how you manage expectations of a final user of model, not about even quality of data. You need it to be consistent, but in most cases you work with data you have, you can't really choose. Does it answer your question, Dmitry?
Yeah, thank you.
Yeah, okay. Okay. I see one. No, nothing. Okay, anything else?
Так, доброго дня. Чи можете ви розкрити питання оптимізації, практичного методу оптимізації, та як можна зменшити похибку навчання практично?
Прошу, Юрій, я почув, що щось про методи оптимізації, але так, щось...
Методи оптимізації. Розкрити питання методів оптимізації, та як зменшити похибку навчання.
Прошу, але я знову не почув. Прошу написати його у чат.
Так, може, так буде краще? Я
Так.
навушники. Питання відносно методів оптимізації та зменшення похибки навчання. Якісь практичні, можливо, приклади. Як зменшити похибку навчання? Я розумію, що чим більше інформації, тим краще для моделі, тим менше похибка, можливо, якісь методи оптимізації. Питання дуже цікаве.
Я би сказав, що є декілька критичних моментів. Це sorry. Якщо ви використовуєте прості моделі, у вас краще дженералізація, не знаю, наскільки це транслюється на українську, тобто sorry, I'll continue in English. But basically, if you train your models simple, you're less likely to overfit. If you use complex model, they could feed training data, and so you can pretty often overfit. So the most simple way to deal with it is to first thing you need is to split your data set to really train, test data sets and validation sample, especially for a case if you want fine-tune to prevent overfitting. This is just critical. It's simple, it's almost all know, but if it's missing, it could be a real disaster. And then you can use complex algorithms to actually to fit your training data set. One of the most, on practice, one of the most one of the best results you will get with boosting algorithms. Because they are built based on trees, and they are fast. They can approximate almost any environment. And basically, if you set proper criteria of control overfitting, they will give you the most accurate answer if you work with stable data. Of course, if you go with image recognition or text processing, neural networks would be a preferable way to go. And say something concrete, I usually do the following. I look on a data and try to get as much features as it possible, and then drop everything that has that actually just a noise. So to value, just to clean data as much as possible. Also, good practical advice is to clean corner cases. For example, to filter, if you have countries, you can filter countries with small amount of traffic and put all those cases in the others, just to group them. Usually it decreases complexity of a model, and so it adds less noise. This is shortly about it. So basically, form, train, test dataset, use boosting algorithms for table data, and neural networks for image processing, etc. So that is separate domain completely. And in 99% of cases, that would give you good result.
Thank you very much. It's fine answer for my questions. Thanks.
Okay, great.